Alrighty, in this video here, we're going to be talking about lesson 12.2, which will be arithmetic sequences and series. So this one here, we're going to specifically get into more of arithmetic style. Basically, what makes a sequence or a series in arithmetic is each number in the sequence is increasing or decreasing by the exact same amount. So I'm either, adding 5 or subtracting 5 each single time. And that's basically what will make it an arithmetic. And once you determine it's arithmetic or you're told it's arithmetic, there are certain equations that you can use. So here we go. So for arithmetic sequences, we have to find the difference. Just take n plus 1 minus a sub n. This is what your guide tells you, but in reality, just take a sub 2 minus a sub 1. Or if you have maybe a sub 5 and a sub 4, you just take the difference between them. And this is what we call the common difference. All right, the equation, which I showed you in the last section, is a sub n equals a sub 1 plus n minus 1 times d. I think I have the d on the outside on the left side, but it doesn't really matter. And then, so this is how you can find the equation. And then we have how to find the summation. So the sum of the first n terms, whatever those amount of terms are, can be written out as such. So S of n equals n times a sub 1 plus d times n minus 1 times n divided by 2. And you can also use n divided by 2 times a sub 1 plus a sub n. So basically, if you know what a sub n is, and you know what a sub 1 is, then you can just plug it in and move on. A lot of time, a sub 1 and the difference, and really and truly, this might be the easier of the formulas, but you can use either one, and I'll show you how to kind of guide yourself through that. All right, and that's pretty much everything that's in 12.2. Basically, this gives you equations that are specifically for arithmetic. All right, so for the first example here, we'll talk about number 1. Here you're asked to find the explicit formula for the nth term of each arithmetic sequence. So it tells you it's an arithmetic sequence. So you have -2, 1, 4, 7, 10, and then dot, dot, dot. All right, so remember the equation is a sub n equals a sub 1. Again, I'm going to write d right there because that just makes sense. Remember, this is the first term. And then this is what they call the common difference. And of course, your n. So here we go. So I'm going to do a sub n equals, remember this is a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, and so on and so on. So that means that this will be -2 plus the difference here looks like I'm going up 3 each time. Usually when I teach this, I always tell students to verify it does, but since it does tell us these are arithmetic sequences, once you determine the difference, which again, all you have to do is take a sub 2 minus a sub 1, and you would get 3 that way as well if you want it more of a equation form. So in this case, that would be 3 times n minus 1. It's 2 steps after that. Distribute. And then combine like terms. So what they're looking for is 3n minus 5. And then that's it. So let's do a few to make sure that we understand what we're doing. So let's look at number 3. Number 3, you're given 7, 5, 3, 1, -1, and so on and so on. So again, I'm going to look for my difference here. So my difference would be 5 minus 7. So I'm going down by 2. So then my equation would be a sub 1, which is 7. And I'm actually going to do plus -2 for distributing purposes, and then n minus 1. So I'll do my 2 steps. So 7 minus 2n. That's when I'll change it, and this becomes a plus 2. So that'll help me remember to carry the negative with me. So that gives me negative 2n plus 9. All right. Let's do another one. Again, in a different type of form, but still asking the same information. Number 5, you are asked a sub 1 equals 5, and you're told a sub 5 equals 41. All right, to find the difference here, I'm going to do 41 minus 5, but notice there are 4 numbers in between. So it's 2, 3, 4, 5. So I'm actually going to subtract. Really, this is how it is. Think of this as like finding the slope. Y2 minus Y1 over X2 minus X1. So that's how I got 4. So you're going to subtract the largest one. So 41 minus 5 would be 36. 5 minus 1 is 4, which will give you 9. So your difference there is 9. Once you have the difference and you have a sub 1, now you can plug it in. So this would be 5 plus 9 times n minus 1. Distribute this out. So you get 9n minus 9, and then 9n minus 4. All right. So again, when you're not given consecutive, you can use what almost like the slope formula, kind of finding the difference. What is the rate of change just about? All right, let's look at another one like that. Let's look at number 8. Number 8 says a sub 12 equals 43, and the difference is 3. All right, so here's the kicker here. You don't have a sub 1, but you need a sub 1 to be able to build out this equation. So let's see. You can find the a sub 1. So using the formula, using this one here, I'm going to plug in what I know. A sub 12 would be 43. I don't know a sub 1. My difference is 3. My n would be 12. Now I can calculate. So 12 minus 1 is 11. 3 times 11 is 33. And then I would subtract 33 from that. So that gives me 10 equals 1. So now I have my first term. So now when I write out my equation, I would do 10 plus 3 times n minus 1, which will give me 3n minus 3, which gives me 3n plus 7. And so again, they try to confuse you, but again, using that same formula, you can just solve for a different part of it. Let's look at another one. Let's look at number 14. This one's a sub 73 equals 224, and a sub 75 gives you 230. Once again, you don't know the difference, so I'm going to do 230 minus 224 over 75 minus 73. I see that this is just 6 over 2, which is 3. I don't know my a sub 1, so I will just pick one. I'll pick the first one here. So a sub 73 is 224 equals a sub 1 plus my difference times my n. So my n in this case would be 73 minus 1. If you did this one, of course, this would be 230, and this would be a 75. But both ways would give you the same answer. 3 times 73 is 219 minus 3. And so then, oh, I don't know why I did that. Whatever. And then that right there would be 216. You could do 73 minus 1, get 72, and multiply by 3 and just be done with that. I decided to go a different route, apparently. All right, so then I'll subtract 216. So again, this would be 224 minus 216, which would give me 8. So my first term would be 8. So now to write this out, I can say this is a sub n equals 8 plus 3 times n minus 1. Do a little distributing. So this would be 3n plus 5. Right? And so that's kind of the nutshell of using the arithmetic sequence formula to develop a equation for the sequence. All right, let's look at some different type of questions. Let's look at number 45. All right, so number 45 says use the given information about each arithmetic sequence to answer the question. So given that ace of 1 equals -3 and ace of 5 equals 5, what is ace of 100? All right, so you don't want to find the difference and then do this all the way up to 100. You want to develop the equation and then plug in 100 into your equation to answer the question. All right, so the first thing I need my difference. So I'm going to do 5 minus -3 over 5 minus 1. So that right there would mean to add. So that'd be 8 over 4. So my difference is 2. Now I'm going to develop my equation. So ace of n would be -3 plus 2 times n minus 1. So I'll distribute that in. And then I'll combine like terms. So I now get this. Now, if I want ace of 100, so this is what ace of n is. Ace of 100, I'll now do 2 times 100 minus 5. So that'd be 200 minus 5, which is 195, which is a lot better than going from 5 going plus 2, plus 2, plus 2 until I get to ace of 100. All right. So again, using that formula to help you get to the answer a lot faster. All right, let's look at number 46. Number 46 says we have a sequence. So 24, 43, 62, dot, dot, dot. Which term is 955? All right, not an issue. We can look at this and find our difference. So this will just be 43 minus 24, which is 19. That's my difference. And this is my ace of 1. So here we go. So to find out my equation, I would do 24 plus 19 times n minus 1. So I get 24 plus 19n minus 19. So I get 19n plus 5. Now, with this information, this is what my ace of n is. I need to know what is n. So I'm going to let ace of n now be 955. And now I'm going to solve. So minus 5. So I get 950. And then I just need to divide by 19. So 950 divided by 19 gives me 50. So that means that 955 would be how they want the answer. Yeah, is ace of 50. Right? Which again is a lot easier than just adding 19 another 47 times before you get to 955. All right. All right, let's look at another one too. Make sure you have plenty of examples. So let's look at number 47. So in this sequence, you got 1, 4/3, 5/3, and you want to know which term is 25. All right. So you might not right away notice the difference. So we'll say this is 4/3 minus 1. Well, 4/3 minus 1 is actually just 1/3 because this will be 3 over 3. And I can see that I'm just adding a third each time. All right, that's my ace of 1. So now I develop my equation. So 1 plus 1/3 times n minus 1. So that gives me 1 plus 1/3 n minus 1/3. So this gives me 1/3 n plus 2/3, because that's what 1 minus 1/3 is. This is what ace of n is. Again, it wants me to determine which term is 25. So then I'll say 25 is equal to 1/3 n plus 2/3. So I'll start off by subtracting 2/3. And this will give me, let's see, so 25 times 3 is 75 over 3. So that would give me 73 over 3 equals 1/3 n. To get rid of this 1/3, I can just multiply by 3, but then I have to do it over here, and it happens to get rid of it as well. So I see n is 73. So which term is 25? That would be n, or ace of 73. Again, a lot easier than adding a third over and over again. All right, let's look at a different style of question. Let's look at number 59. It says, find the value of the partial sum for each arithmetic sequence. So you're given 100, I equals 1, and 3i minus 8. Again, I don't want to have to plug in 1 all the way through 100 and add all of those. That would take me forever. So if I want, I can use my summation formula, which would be, I'm going to use the easier one to see if I can. Ace of 1 plus ace of n. I find this to be easier. You can use the other one as well because you just need to know the difference. Ace of 1 and n. But I don't know. I'll do, I just find this one to be easier. And the reason I say that, because I can easily come over here and I can find ace of 1. So ace of 1 will be 3 times 1 minus 8. So that's going to be 3 minus 8, which is -5. I now have ace of 1. Now I just need to find ace of 100. So if I find ace of 100, that would be 3 times 100 minus 8. So that'd be 300 minus 8. So that'd be 292. So that'd be ace of n. And then my n is 100. So then I can come over here and do 100 divided by 2 times -5 plus 292. And I would get my answer. So here we go. So that's going to be 292 minus 5 basically, which would be 287. So this will be 50 times 287. So I multiply that by 50 and I would get 14,350 as my answer, which again is a lot better than adding 100 numbers. Now you can use the other way as well. You would just plug in the D for difference. This right here would be the difference in arithmetic sequence. Other than that, and then you wouldn't have to find ace of n. So you would just have to find you'd still have to find ace of 1. This is the difference, and then you would plug it in as such and have a little bit more arithmetic to do. All right, but both cases would give you the same outcome. All right, but let's do a couple more to make sure we fully understand the concept here. So let's look at number 60. 60, you're presented with 50. I equals 1, -2i plus 5. So again, let me use the other way just so you can see it. So the other formula would be n times ace of 1 plus d times n minus 1 times n divided by 2. Again, to me, this seems like a lot. But it'll give you the same answer. So I can find ace of 1. So that's -2 times 1 plus 5. So this would be -2 plus 5, which would give me 3. This is my d. And this again would be my n right here. So in this case, this will be 50 times 3 plus -2 times 50 minus 1 times 50 over 2. So this gives me 150 plus -2 times, let's see, 49 times 50, divide that by 2, gives me 1,225. Multiply then that back by 2, and that goes back to -2,450 with the 150 on that. So now I'm going to subtract 150 from that, and I would get -2,300. And there you go. So again, both formulas work. Use whichever you like best. All right, so now I'm going to do number 62. Number 62 gives it to you as a sequence. So 3 plus 11 plus ... plus 795. All right, the route you want to go here is you just kind of want to figure out what term this is, then we can plug it into our equation. So we start off, this is my ace of 1. So my D would be 11 minus 3, which would be 8. So then my formula would be ace of n equals 3 plus 8 times n minus 1. So that'd be 3 plus 8n minus 8. So that'd give me 8n minus 5. All right, now that I have this equation, I need to figure out what this is. So this is what ace of n is. So 795 would be 8n minus 5. What is my n? So let's add 5 to that. So that'd give me 800 equals 8n divided by 8. So I see n is 100. So now when I plug it into my series, I actually have most of my stuff. So again, plugging into this, I'm going to plug into the other one. So there's all my information. I now know that this n right here is 100. So this would be 100 divided by 2. Ace of 1 is 3. Ace of n, you're already told what ace of n is. It's 795. So this would be 50 times 798. So 50 times 798 gives me 39,900. All right. So again, hopefully that gives you a lot of different scenarios. Of course, if there's word prompts to be given, we're going to find it to give it to you. So let's do some word problems as well. Let's look at number 71. All right, number 71 says Cynthia borrows $21,000 interest free from her parents to help pay for her college education and promises that upon her graduation, she'll pay back the sum beginning with $1,000. So the first payment's $1,000, and increasing the amount by 1,000 each successive year. So my difference would also be $1,000. How many years will it take her to repay the entirety of the $21,000? So this will be like my ace of n. All right, so here we go. So to plug in our formula, again, we'll start off with this guy right here. I'll write it one more time for you. Let's plug in our stuff. So ace of n would be 21,000. Ace of 1 was 1,000. That was her first payment. The difference, she says, is going to increase by 1,000 each year. I just don't know how many years that's going to take to pay it off. So here we go. So that gives me 1,000 plus 1,000 in minus 1,000. Oh, nice. There's ace of 1, which is 1,000. Thousands would cancel. It would take 21 years? No, that'd be if you only paid 1,000 each time. Did you go from 1,000 to 2,000 to 3,000? You know what? This is the summation formula. Okay, I got you. Hold on. Because we would get to 21 in 21 years. So the S of n, again, this is all adds up to that. Here we go. So we'll use this formula. All right, so um, well, I guess you would need the n anyways, because you would need, well, I don't know n. I know that the summation would be 21,000. I don't know what n is. I know my first term is 1,000. I know the last term. I don't think I know the last term. I can't use this one. I'm gonna have to use the other one. So let's use the other formula. So that'd be S of n equals n times ace of 1 plus d times n minus 1 times n divided by 2. All right, so I know my summation has to be at 21,000. I don't know my n. But I do know my ace of 1. My ace of 1 was 1,000. I know my difference is 1,000. And then I don't know this. So let me go ahead and just simplify this. This would be n squared minus n divided by 2. Okay, so let's do this. So it'll be 1,000 n. This would be 500. So this would be 500 n squared minus 500 n. So then that would be 500 n squared plus 500 n equals 21,000. I'm going to divide everything by 500 to get these numbers a little bit smaller. Give me n squared plus n, and then this would be 42. So to make this a quadratic, I need to subtract 42 on both sides. So this would be 0 equals n squared plus n minus 42. And now we just got to factor. So two numbers that multiply negative 42 but add up to 1. That'd be 6 and a 7. And then I want it to be a positive 7, or positive 1 and a negative 6. So that'd say n equals 6 and n equals negative 7. Well, you can't have a negative n, so therefore it must be 6 years. All right, so I started off, so kind of help you with the thought process there. I started off with a general formula to see if I could go from there. The issue is it would just tell me it would take 21, so I could. No, I couldn't even use that because it's the summation. So I had to use the summation formula. I couldn't use the other way because I don't know that last term. If I knew the last term, I could probably just quickly just do the math. Now, granted, this was 6 years, so maybe I could have just done 21,000 minus 1,000, minus 2,000, minus 3,000, minus 4,000, and then done it 6 times and got the answer. But I didn't know it's going to be that short. It could have been 20 years, and I don't want to have to keep subtracting that many times. So there's quite a few ways to probably approach that problem, but this is probably the more algebraic way. Let's look at another one. Let's look at number 72. Number 72 says a certain theater is shaped so that the first row has 30 seats. All right, there's your ace of 1. And moving towards the back, each successive row has 2 seats more. So that means the difference is increasing by 2 than the previous one. If there are 40, so that means my n is 40, how many seats does the last row contain? So I'm looking for ace of 40. And how many seats are there altogether? So I'm also looking for S of 40. All right, so here we go. So to find ace of 40, I need to find ace of n. So that's going to be 30 plus 2 times n minus 1. So that'd be 30 plus 2n minus 2. So that'd be 2n plus 28. That would be my ace of n. So to find 40, ace of 40 would be 2 times 40 plus 28. So that'd be 80 plus 28. So that'd be 108. So ace of 40 would be 108. So the last row would have 108. That answers the first question. The second question, I need to find the summation. So again, I'm going to use the n divided by 2 times ace of 1 plus ace of n. So in this case, that would be 40 divided by 2 times my first, which was 30, plus my last, which was 108. That's 20 times 138, which would give me 138 times 20, 2,760. I don't know why I added a 0 here. So 2,760 seats. So you go. So that one's a little bit quicker of a process there. Let's look at one more word problem. Make sure you have all the word problems you need. So let's look at number 75. It says a man decides to lease a car and is told that his payment to the car dealership will be $50. All right, there's your first. It says $50 in the first month. He is also told that every month thereafter for the next 60 months, his payments will increase by $20, or sorry, $25. So the difference is 25. How much is his monthly payment after 2 years? Well, monthly payment, that means that'd be 24 for 2 years. And then how much has he paid in the first 2 years? So I also need to know what S of 24 is. So we start off by, what was the first question? How much is, so I'm also looking for ace of 24 as well. And that's where we'll start. So ace of n would equal 50 plus 25 times n minus 1. So it'll be 50 plus 25n minus 25. So this would be 25n plus 25. That's my ace of n. To find my ace of 24, this is now 25 times 24 plus 25. So 25 times 24 plus 25 gives me 625. So that means his 24th payment will now be $625. If anyone tries to convince y'all to do that, do not do this. And then my S of 24 would be n divided by 2. So that's 24 divided by 2 times my ace of 1, which was 50, plus my ace of n, which is 625. So this would be 12 times 675. So 675 times 12 gives me $8,100. So if he does this of his car, he's paid 8,100. Maybe it is a good deal. I don't know. Doesn't seem like a good one to me. But there you go. So there is your two answers. That's how much the monthly payment is after 24 months. That's how much you've paid for the car in 24 months. All right, so hopefully that is plenty of examples to help you with arithmetic. There's only one more section left, which is geometric, and that will be the last video for this semester. And then you just have test number 4 and then the final exam. And then I'll post something to discuss the dates and stuff like that, but it's already on the syllabus. But if you ever need any other questions, please reach out. Until the next video.